Hey there, and welcome back, Math Compadres. This is your host for math. Today we're looking at lesson 5.6, the sixth lesson in chapter 5, and standard form of a linear equation. Please write both of these things down at the top of the page in your math notebook so you know what it is you're working on. It's always good to be organized, and this will help. All right. Now that we've expanded our there, that's way better. Okay, now most of the linear equations we deal with are going to be in slope-intercept form, and I love slope-intercept form, of course. Y equals mx plus b, where m is the slope, b is the y-intercept. Remember, the slope is the steepness of the line, right? It's how the line moves. I think that's why they use m. And remember, it is always the rise over the run. And so that rise, it can go up or it can go down, but the run is always from left to right. And B is the y-intercept. It's where it crosses the y-axis. Right? Where does it cross the y-axis? We say that's where the line begins. If we're going to graph it, that's where we always start, on the y-axis. Okay? Now, in the last lesson, you learned about the point-slope form, where m is still the slope, and it still describes all those things. And x1 and y1, that's a point on the line. So we use, y1 and x1. Those are points on the line. And oftentimes they are given to you. Sometimes you have to find them and identify them yourself from the graph. But whatever, they're there. So we learned about that in the last lesson. Another very popular form that we will use is the standard form equation. Standard form equation is a times x plus b times y equals c, where a, b, and c represent real numbers. Not fake numbers, real numbers. Now, notice that the variable terms on the left side of the equation, right, those are both here. We've got the x and the y both on the left-hand side of the equation, and our constant is over here by itself on the right. And that's what makes it standard form. And it's really handy to do certain things that we'll talk about later. Now, we can convert other equations to standard form with integer coefficients. We have to have integer coefficients, positive and negative numbers. So let's take a look at this very first one here. Let's get started. So y equals 2/5 x minus 3. Now I'm going to rewrite that one real quick. Y equals 2/5 x minus 3. Now notice we have to have integer coefficients. I notice we don't have an integer coefficient here. So the very first thing that I'm going to do is I'm going to multiply everything in this equation by the denominator of our fraction, which happens to be 5. So I'm going to multiply everything times 5. That means I'm going to multiply 5 times y, which is 5y. 5 times 2/5 x works out to be just 2x. And 5 times negative 3 is negative 15. Now, if you're wondering how I was able to take 5 and multiply it times 2/5 x, let me show you real quick over here. So 5 times 2/5. 5 over 1, first of all, then I multiply straight across. 5 times 2 is 10, 1 times 5 is 5, and 10 divided by 5 is 2. So that's how I ended up with 2x there. All right, now let's get back to what we were working on. Now, I want to have all my variable terms on one side, so I'm going to subtract 2x from this side, and I have to subtract 2x from this side. It'll cancel it out on this side, and so now I have negative 2x plus 5y, because remember that's a positive 5y, equals negative 15. Now that's great. I like this. Now we can also have another version of this where we could multiply everything in this equation by negative 1 and change the signs of everything. So negative 1 times negative 2x would be positive 2x. Negative 1 times positive 5 would be negative 5y. And negative 1 times negative 15 is positive 15. Okay, these are both okay. They're great. I prefer this one because the x term is positive. Anyway, that's how that is. Converting slope-intercept into standard form. Now, we can also write the standard form equation of the line that passes through this point with a slope of -2. So we have to start with the point slope form. So let's do that. Here's our point slope form, y minus y1 equals m times quantity x minus x1. Let's just substitute these points. y1 is 3, y minus 3 equals, the slope is -2 times x minus -4. Now, minus -4, of course, we recognize that we have to fix that. So this is -2 times x plus 4 because we are adding the opposite. All right. And we have y minus 3 over here. Okay, now let's distribute -2 into x plus 4. And so -2 times x is -2x. -2 times positive 4 is -8. And y minus 3 over here. All right, well, we're getting closer. We want to get all our variable terms to the right-hand side. So let's do that. We're going to add 2x. So we get rid of it from this side. We add 2x to this one. Those cancel each other out. And now I have 2x plus y minus 3 equals -8. Now my next step is to get rid of the -3. So I'm going to add 3 to both sides. Those cancel out. And now I have 2x plus y equals -8 plus 3 is -5. Okay, now if I wanted to, again, I could multiply everything by -1, which would give us then -2x minus y equals +5. Now you might ask, hey, why is that y? It's a single. There's no number with it. Well, that number is implied. So we can put an imaginary 1 there and say, well, that's 1y, -1y. That's if you really need it. You may not. But if you need it, put it there. Now, the real-world application of the standard form comes into play when we talk about things like this problem here. Todd is in charge of buying hamburgers and chicken legs for a barbecue. The hamburger costs $4 per pound and the chicken legs cost $6 per pound. And he only has $60 to spend. What's the equation that models the different amounts of hamburger and chicken legs that he can buy? Well, to answer this question, we have to come up with variables because we want to know the different amounts of hamburger and chicken legs. So I am going to let x equal the number of pounds of hamburger, and I'm going to let y equal the number of pounds of chicken legs. Now, I know that the hamburger costs $4 per pound, so $4 multiplied by the number of pounds of hamburger plus $6 per pound multiplied by the number of pounds of chicken legs that he buys has to equal $60. All right, and there we have our equation already set up. The amount of hamburger, the amount of chicken multiplied by the cost per pound for each of them should equal the total cost here. That's the equation that models the amount of hamburger and chicken legs that he can buy. And then we could come up with different scenarios where if he buys 1 pound of hamburger, how many pounds of chicken legs could he buy, and so on and so forth. So that's where we're at. And you could create a table of values. Right? Just remember, everything has to equal 60. So if x is 1, so that'll be 4 times 1, that'll be $4. 60 minus $4 is 56. How many times will 60 or 6 go into 56? So by 9.3, a little over 9 pounds of chicken legs. Sorry, that's 1 pound there, my bad. All right, if he buys 2 pounds of hamburger, that's $8. 60 minus $8 is 52. 52 divided by 6 is 8.6. So we could buy 8.6 pounds, and so on. And we could keep on going, but we don't need to. This just helps us come up with the idea of why the standard form equation works. Some number times x plus some number times y equals some other number. Standard form. Now, here are all the equations that we've used so far that have been helpful to us. We have the slope-intercept form, point slope. We know that a vertical line with an undefined slope is x equals some number. A horizontal line with zero slope is y equals some number. And standard form, ax plus by equals c, where a, b, and c are real numbers, and a and b are not, both 0. All right, that's it, folks. Here are your practice problems for today. You can stop the video here, or you can go back to the slide where you found this and click on practice work, and it'll bring it up. Good luck with this. Have a great day. Don't forget to be awesome. I'll see you next time. Keep on mathin'.